ideal solutions which shows negative deviation from Raoult's law. For these solutions, delta H is negative. Delta H mixture is negative. Delta V mixture is negative. For example, liquid A 20 ml, B liquid 50 ml. Volume of the mixture less than 70 ml. So here volume occupied by the molecules decreases. See, understand clearly. See, volume of molecules of A, volume occupied by molecules of A 20 ml. Volume occupied by molecules of B 50 ml. So even if they are mixed together, they should occupy 70 ml. But they are occupying less than 70 ml means intermolecular distance between molecules, right? Intermolecular distance decreases. Intermolecular distance is decreasing means intermolecular attractions are increasing. Is it clear? See, for example, in a liquid, intermolecular attractions are weak. In B liquid also, intermolecular distance is more, intermolecular attractions are less. Right? Weak intermolecular attractions. Intermolecular attractions. Now, if these two are mixed together, then intermolecular attractions increases. So, in A, intermolecular attractions are weak, in B, intermolecular attractions are weak, but in A and B mixed together, then intermolecular attractions became strong. Such solutions exhibit negative deviation from Raoult's law. See, as intermolecular attractions are increasing, then they liberate energy in the form of heat. That is why delta H is negative. Intermolecular attractions are increasing means system energy decreases. Energy of the system decreases. So, system liberate energy to the surroundings. Therefore, process is exothermic. CH3, C double bond O, CH3. Acetone, non-polar solvent. Treated as non-polar solvent. Not like carbon tetrachloride because dipole moment is there. Therefore, it is slightly polar. Similarly, CHCl3 broadly, it is also considered as a non-polar solvent, chloroform. In acetone, molecular distance is more, tendency to escape from liquid into vapor is more because intermolecular attractions are very weak. Same in case of chloroform also. Intermolecular attractions are weak. Tendency to go into the vapor state is more. Therefore, they form more vapor pressure. But when acetone and chloroform are mixed together, see, CCl3H. CCl3 is a strong electron withdrawing group. Actually, carbon is less electronegative only, but chlorine is more electronegative. As chlorine is pulling electrons towards itself, positive charge on carbon increases. As a positive charge on carbon increases, electronegativity of the carbon increases. As electronegativity of carbon increases, it pulls the bond pair of electrons in CH bond towards itself. As a result, this is compensated because it pulled a bond pair of electrons towards itself. As a result, partial positive charge is developed on hydrogen. Therefore, this hydrogen is acidic hydrogen. You can treat it as acidic hydrogen and can able to form intermolecular hydrogen bonding. Clear? Don't take CCl single bond. Take it as CCl3. As three chlorine atoms are bonded to carbon, they pull the bond pair of electrons towards themselves because chlorine is more electronegative than carbon. As a result, more positive charge is developed on the carbon. As a result, its electronegativity increases. So, to compensate the partial positive charge developed on the carbon, it pulls the bond pair of electrons towards itself in CH bond. So, finally, result is hydrogen acquires more quantity of partial positive charge and becomes acidic and can able to form intermolecular hydrogen bonding. Acetone, two methyl groups bonded to carbonyl group, C double bond O group. C double bond O, one is sigma bond, pi bond. Carbon is less electronegative, oxygen is more electronegative, and pi electrons are loosely held between carbon and oxygen. Due to this, carbon gets partial positive charge and oxygen gets partial negative charge, and moreover, three methyl groups are there. These are plus I groups. So they push bond pair of electrons towards carbon. As a result, electron density on carbon increases. Therefore, easily pi electrons shift to oxygen. Thereby, oxygen gets a partial negative charge. When these two are mixed together, acetone and chlorine mixed together, there exists a strong, not strong, weak electrostatic force of attraction. Weak electrostatic force of attraction. Weak electrostatic force of attraction that exists between partially negative charged oxygen of acetone and partially positive charged hydrogen of chloroform. So like these intermolecular attractions, intermolecular distance decreases, intermolecular attractions increase. Clear? So therefore, as intermolecular attractions increases in the liquid phase or in the solution phase, then escaping tendency or vapor forming tendency decreases. So lesser the vapor pressure is less. More vapor pressure is more. Less vapor, then vapor pressure will be less. Clear? For these solutions, PA is less than P naught A XA. PB is less than PB naught XB. P total is less than PA plus PB. P total is less than PA naught XA and PB naught XB. Now for these solutions, see, vapor pressure composition graph. Ideal behavior. Dotted line shows ideal behavior. So at any composition Pa is less than P naught AXA, and at any composition PB is less than P naught PB naught and XB, and at any composition total vapor pressure is PA plus PB. P total is less than PA naught XA plus PB naught XB. Clear? At any composition, remember, from left side, right hand side, at any composition, P total is less than PA plus P. Right? These solutions are examples of maximum boiling azeotropes. Maximum boiling azeotropic, because vapor pressure decreasing, so that is why boiling point increases. So for example, A liquid boiling point 75 degrees Celsius, B liquid boiling point 100 degrees Celsius. Now mixture boiling point is greater than 100 degrees Celsius. So at constant temperature, both A and B liquids vaporizes. That is why it is not possible for us to separate liquids from azeotropic mixture. Right? Suppose if you have any doubts regarding this topic, then you ask me in WhatsApp. No problem. I will explain you. Heptane and octane form ideal solution. At 400 Kelvin, the vapor pressure of the two liquids are 105.2 kilopascals and 46.8 kilopascal respectively. will be the vapor pressure? What will be the vapor pressure of mixture of 25 grams of heptane and 35 grams of octane? So we have to imagine, we have to assume heptane and octane mixture form an ideal solution. The vapor pressure of two liquids are given. So heptane vapor pressure is 105.2 kilopascal and octane 46.8 kilopascal. What will be the vapor pressure of mixture of 25 grams of heptane and 35 grams of octane? Heptane C7H16, so molecular weight is 100. Octane C8H18, molecular weight is 104. 114. Right? Now, number of moles of heptane 25 by 100. Number of moles of octane 35 by 114. Total number of moles is 25 by 100 plus 35 by 114. This is total number of moles. Mole fraction of heptane is number of moles of heptane by total number of moles, 25 by 100 by 25 by 100 plus 35 by 114. Similarly, mole fraction of octane is number of moles of octane by total number of moles, 35 by 114 by 25 by 100 plus 35 by 114. So calculate mole fraction of octane, mole fraction of heptane. Then A is heptane and B is octane. Now P total is equal to P naught A XA plus P naught B XB. So P total is equal to P naught A 105.2 into mole fraction of A. Say this is J, this is H. So substitute here J value plus 46.8 into H value. You will get the answer. maximum questions, NEET entrance examination, you will get the same model. They will give number of moles instead of mass. They may give number of moles. Then you can solve easily. Vapor pressure of solution containing 3 and 1 mole respectively of X and Y is 550 mm. At the same temperature, another solution containing 4 mole and 1 mole X and Y respectively, the vapor pressure became 560 mm. At this temperature, calculate vapor pressure of X and Y in pure form. So, vapor pressures of X and Y are not given. Okay, now see, this is first solution. Number of moles of X is 3, number of moles of Y is 1, and mole fraction of X is 3 by 4, mole fraction of Y is 1 by 4. So, P total is 550 is equal to P naught X into its mole fraction 3 by 4 plus P naught Y into its mole fraction 1 by 4. So this is equation 1. Now second solution. In second solution, number of moles of X is 4, and number of moles of Y is 1. Number of moles of mole fraction of X is 4 by 5. Mole fraction of Y is 1 by 5. And total pressure became 560, right? So 560 is equal to P naught X 4 by 5 plus P naught Y 1 by 5. This is second equation. So 3 by 4 P naught X plus 1 by 4 P naught Y is equal to 550. 4 by 5 P naught X plus 1 by 5 P naught Y is equal to 560. Now how to solve this question? Say mathematical equation 1 and 2. So multiply first equation with 4. Okay. So now I am removing this. I am removing this part. Multiply the equation with 4. Equation 1 with 4. 3 P naught X plus P naught Y is equal to, we are multiplying with 4, right? So 4000, 4 into 5, 4 into 550, 2200. Say this is equation 3. Next, multiply the equation with 2, with the 5. Then 4 P naught X plus Py naught is equal to 4, multiply with the 5. 2800. Now from equations 3 and 4, so subtract equation 3 from 4, you will get 7 P naught X equal to 7 P naught X, no, P naught X is 600 mm. Now substitute P naught X value in equation 3. 3 into 600 plus Py naught is equal to 2200. So Py naught is equal to 400 mm. So this is the answer. Gas and liquid type of solution. In gas and liquid type of solution, gas acts as solute and the liquid acts as solvent. So gas dissolves in the liquid to form solution. Okay, in formation of solution, gas will dissolve in the liquid. Gas will dissolve in the solvent to form solution. Solubility of a gas in a solvent depends on three important factors: nature of gas and also nature of solvent. Number two, temperature, and number three, pressure. See, if you take first point, nature of the gas and solvent, there is a principle for solid in liquid type of solutions, liquid in liquid type of solutions, that is applicable for gas and liquid systems also. That is, like dissolves like dissolves like. So polar gases are soluble in polar solvents like water. Polar gases means sulfur dioxide, ammonia, HCl, dinitrogen pentoxide, so on and so forth. These are highly soluble in water. Highly soluble in water. Whereas hydrogen, oxygen, nitrogen, these are non-polar. So therefore, solubility of these gases is very, very less. Now another important factor is temperature. See, when a gas is sent into solvent, then gaseous molecules enter in the solvent and form a homogeneous mixture known as a solution. Gaseous molecules form homogeneous mixture with solvent molecules due to intermolecular attractions. If intermolecular attractions are strong, then more amount of gas will dissolve in the solvent and form solution. So here also intermolecular forces of attractions are responsible for formation of solution. So due to intermolecular forces of attraction, energy of the system decreases. The decrease in internal energy of the system liberated in the form of heat. Therefore, the process is exothermic process. See, in case of liquid in liquid type of solutions, solid in liquid type of solutions, they are irreversible. But whereas liquid gas in liquid type of systems are always reversible and exothermic also. Therefore, at equilibrium state is established. Right? Now, according to Lee-Chatelier principle, reaction is exothermic. Therefore, low temperature is favorable condition. So therefore, with the rise in temperature, equilibrium shifts to left hand side. Solubility of the gas decreases. If temperature is decreased, equilibrium shifts to right hand side and the solubility of the gas in the solvent increases. And third one is important factor, pressure. If you increase the pressure exerted by the gas, then more quantity, more amount of gas enter in solution. Therefore, solubility of the gas increases. According to Henry's law, at a given temperature, with increase in pressure exerted by the gas, if pressure exerted by the gas is increased, the mass of the gas entered in the solution also increase. Mass of gas entered in solution also increase. So M by P of gas is constant at constant temperature. Now, at constant temperature, pressure exerted by the gas is directly proportional to mole fraction of the gas in solution. So pressure exerted by the gas is equal to a proportionality constant Kh known as Henry's constant into mole fraction of the gas. Remember, the value of Kh depends on several factors: nature of the gas, temperature, so on and so forth. For a given gas, Kh is also not constant. Even for a given gas also, Kh is not constant. For a given gas, remember, very important, for a given gas, at a particular temperature, KH is constant. So, for a given gas, if you change temperature, KH value also changes. Remember, units of KH is units of pressure. If pressure is expressed in atmospheres, KH value is in atmospheres, because mole fraction has no units. Number of moles of gas by number of moles of gas plus number of moles of solvent. Number of moles of gas is very less than number of moles of solvent. So therefore number of moles of gas plus number of moles of solvent is equal to number of moles of solvent. So therefore pressure exerted by the gas is equal to Henry's constant into number of moles of the gas by number of moles of solvent. So they will give the data directly, KH value they will give, everything they will provide. Then you calculate and you substitute in this equation and finish it. But only problem is with the simplification, because solubility of the gas in a solvent at a particular temperature is very less value. So that is why simplification will be little bit hard. But solving problem is very easy. Clear? Now probability of getting problem on Henry's constant in NEET examination is very rare. It is about 10 power minus 3% because simplification we can't do in a single minute, in 1 minute. Clear? So I will give some 2 or 3 problems in the next class, but I will not solve. Try to solve those questions, and after that, see, I finished 2 topics in plus 2, that is surface chemistry, solutions and electrochemistry. Next class I start with surface chemistry. This is also not important, but you will get one question from surface chemistry. You will get one, or one is maximum, 2 rare in solutions, but sometimes electrochemistry is very big topic, so there is a chance for getting 2 questions, and most important also, right?